Okay, so this is the end of chapter 7, and we're in section 8. We're going to talk about scientific notation. We're going to convert between decimal notation and scientific notation, and we're going to multiply and divide in scientific notation. In technical work, you will often deal with very small and very large numbers that may require a lot of space to write. For example, a certain computer function may take 5 nanoseconds, which is 0.00, whole bunch of zeros, right? 5 seconds in electricity, and 1 kilowatt hour is equal to 3,600,000 joules of work. Rather than take the time and space to write all those zeros, we often use scientific notation to express such numbers. In scientific notation, 5 nanoseconds would be written as 5 times 10 to the negative 9th power seconds, and 1 kilowatt would be 3.6 times 10 to the 6 joules. As you can see, a number written scientific notation is a product of the number between 1 and 10 and the power of 10. A number is expressed in scientific notation when it is in the form p times 10 to the k, where p is the number less than 10 and greater than or equal to 1, and k is the integer. Numbers that are powers of 10, they're easy to write in scientific notation. 1,000 is 1 times 10 to the third. And you can look at that and notice that we have 1, 2, 3 zeros, so we've got 10 to the third. 100 is 1 times 10 to the second because we have 2 zeros. 10 would be 1 times 10 to the first, and so on. In general, to write a positive decimal number in scientific notation, first write it as a number between 1 and 10 times the power of 10, and then write the power of 10 using an exponent. So if we want to follow this example, we've got 3,600,000. So what we want to do is start with our number, and keep in mind that you want the number in the front. So when we're writing times 10, this number in the front has to be at least 1 and smaller than 10. So to make that happen, when we look at this number, we would need to make it be 3.6 because it has to be at least 1 and it has to be smaller than 10. So right now our decimal is here, so we would want to move it 1, 2, 3, 4, 5, 6 places to get it between the 3 and 6, which is why this is 3.6 times 10 to the 6th. On this number, we've got 0.0004. We know that we want the number in the front to be between 1, or at least 1, and smaller than 10, so we would make that be a 4 times 10, and we're looking for what power that would be. So I need my decimal to end up here so that it turns into 4. So I'm going to go 1, 2, 3, 4. And so this time, if you'll notice, we moved our decimal to the right, and when you move your decimal to the right, it's going to be to a negative power. If you move your decimal to the left, it's going to be a positive. So, steps for converting to scientific notation. Step number 1, if the number is given without a decimal point, rewrite it with a decimal point. Mark an arrow after the first non-zero digit, and then count the number of digits from the mark to the decimal point. Place the decimal point in the mark position. Use the resulting number as the multiplier p. Use the number of digits from the mark to the original decimal point as the exponent. If the shift is to the right, the exponent is positive. If the shift is to the left, the exponent is negative. Okay, so using their method, if we have the number 150,000, they say put the decimal there. And I like to go ahead and write down that I know it's some number times 10. Okay, and then they said, well, find the first non-zero number and go to the next digit and know that, put you an arrow there, knowing that that's where my decimal needs to go. So we know this needs to be 1.5. Then we're going to move it 1, 2, 3, 4, 5 times to the left. And since we're moving it to the left, it's going to be positive. Okay, this one, making sure I have the right amount of zeros. That's another thing about scientific notation. A lot of times it's confusing to have to put a weird number of zeros. You have to go back and count multiple times. But we're supposed to find the first non-zero digit, which is the 2, put our arrow behind it. Okay, and we're going to move our decimal, so we know it's going to be 2.05, the remaining part. We're going to move our decimal 1, 2, 3, 4, 5, 6 places to the right, so it's going to be a -6. Okay, 47, we know we're going to do blank times 10. A lot of people are like, I don't even need to do anything with that one because it's 47. Well, remember that the number in the front has to be between 1 and 10. And this is not, so it has to be at least 1 and smaller than 10. So we put our decimal where it goes. We put an arrow after the first non-zero digit, so we know we're looking at 4.7, and we would only have to move our decimal 1 place to the left, so 10 to the first power. When a positive number greater than or equal to 10 is written in scientific notation, the exponent is positive. When a positive number less than 1 is written in scientific notation, the exponent is negative. When a number between 1 or 10 is written in scientific notation, the exponent is 0. To convert a number from scientific notation to decimal form, shift the decimal as indicated by the power of 10 to the right for a positive exponent, to the left for a negative exponent. Then you can attach additional zeros as needed. Okay, so we've got 3.2 times 10 to the 4th. Okay, so right now our decimal is right here, and the 4 tells us we're going to go to the right 4 decimal places, so 1, 2, 3, 4, and we're going to need to put zeros in all of these places to fill the number up, so 32,000 would be the correct answer if we were going backwards. Okay, if I've got 2.7 times 10 to the -3rd, then I'm going to write down 2.7. But because it's negative, I'm going to move my decimal to the left 1, 2, 3 spaces. So we're going to put zeros to fill up the rest. So our answer is 0.0027. Scientific notation is especially useful when we must multiply or divide very large or very small numbers. Although most calculators have a means of converting decimal numbers to scientific notation and can perform arithmetic with scientific notation, it is important for you to be able to do simple calculations of this kind quickly and accurately without a calculator. So, to multiply or divide numbers given in exponential form, use the rules given previously. So, if we've got a base, same base, then what we do with the exponents, if we're multiplying, we add them. If we have the same base number and we're dividing, then we're going to subtract our exponents. So to multiply numbers written in scientific notation, work with the decimal and exponential parts separately. So I've got A times 10 to the B times C times 10 to the D. Well, these parts right here have the same base, and we're multiplying, so we're going to add the exponents. Then they've taken their A and multiplied it by C in the front. Okay, so if I want to do 26,3,500, the first thing they did is write it in scientific notation. Okay, now they've taken and they've regrouped the numbers. So they took the 2.6 and the 3.5 and put them in the front, and they took their 10 to the 4th and 10 to the 6th that have the same base and put it in the back. 2.6 times 3.5 is 9.1. They took their 4 and their 6 because they had the same base and added them together. So the answer was 9.1 times 10 to the 10th power. When dividing numbers written in scientific notation, it may help to think of the division as a fraction. So they've written A times 10 to the B on the top, C times 10 to the D on the bottom. Then they grouped their number together and their tens to the power together. Okay, now to do this problem, you're going to do A divided by C, which is your numbers in the front. Then you're going to subtract your exponents on the base that's both tens. So if we've got 45,000 times 0.0018, first thing they did is change it to scientific notation. Then, if you'll look, they've grouped our 4.5 and our 1.8 together. We've grouped our tens together. 4.5 divided by 1.8 is 2.5. Then they took our exponents, and since we're dividing, we're going to subtract. So 4 minus a negative 3, which gets us 10 to the 7th power. If the results of a calculation is not in scientific notation, that is, if the decimal part is greater than 10 or less than 1, rewrite the decimal part so that it is in scientific notation. So if we've got this, which is a lot of zeros and then a 7-2 divided by this, the first thing they've done is rewrite it in scientific notation. They've grouped their numbers together and their tens to a power together. 7.2 divided by 9 got us 0.8. Then you're going to subtract your exponents here. So we've got a negative 6 and a negative 4. So that's going to be negative 6 minus negative 4. And remember, minus minus is a plus. So this whole thing turns into negative 2, which is why they've got negative 2 right here. But 0.8 is not a number between 1 and 10, so this is officially not in scientific notation. So we're going to need to move our decimal over one space to get it to be 8. If I move my decimal over one space to the right, I'm going to have to add 1 to this negative 2. So, I'm sorry, if I move my decimal to the right, I'm going to have to subtract 1 from this negative 2. So I'm going to get 8 times 10 to the negative 3, because we've moved our decimal to the right once. If a very large or very small number contains too many digits to be shown on the display of a calculator, it will be converted to scientific notation. For example, if you typed in 6,480,000 times 75,000 on a calculator, the answer will be displayed in one of the following ways. You might see 4.86 times 10 to the 11th, 4.86 to the 11th, and the last one is 4.86 E11th, which all of these mean 4.86 times 10 to the 11th. Our calculator, if you're using the TI-84, is going to show it like this. In the division, 0.000006 divided by, I think that is 48 million, right? It's going to give one of these answers, 1.25 times 10 to the negative 13th, 1.25 negative 13th, 1.25 e to the negative 13th, which is, this is the one our calculator says. But every single one of those means 1.25 times 10 to the negative 13th. You may also enter numbers in scientific notation directly into your calculator using a key labeled EE, EXP, or 10 to the x power. For this calculation, you could just type in 6 times 10 to the negative 6 divided by 4.8 times 10 to the 7th, and you would get your answer. If you wish to see all the answers in scientific notation, look for a key marked SCI for Science/Engineering, or use the Setup or Mode menus to switch to scientific mode. At a solar energy plant being built in the Mojave Desert. Power is generated using 173,500 helostats. Each helostat has and that may be helostat, I don't know, has a luminance value of 1,340,000,000. To calculate the total luminance generated at the plant, we multiply the number of heliostats by the luminance value of each heliostat. Because the calculation involves very large numbers, we use scientific notation to simplify the multiplication. So the first thing they did is they took this number, and they put them in scientific notation. Okay. The next thing that they did is they grouped these two numbers together. They grouped their powers of 10 together. And then we're multiplying, so we're adding 5 plus 9 to get our 14. And then 1.735 times 1.34 gave them their 2.3249 times 10 to the 14th lumens. If you just went and typed this in the calculator, okay, your calculator would probably give you the answer in scientific notation. It might look something like 2.3249E14 instead of this. But you don't have to convert it to scientific notation to be able to just type it in the calculator. So that's the end of Chapter 7.